Thanks, Debbie. It's always great to spend time with Daan. He's always doing some amazing stuff with his Codera platform. It was such an honor to work with him at the Reserve Bank. So really interesting to see what he's doing, and certainly hope we can learn a lot. I'm sure we will. Thanks, Daan.
Thanks so much, Howard. Can I just confirm that you can see my screen?
Yes, we can.
Okay, excellent. So thank you for the opportunity. And today I'm going to be speaking about the importance of automating analytics at an enterprise level. And I'm going to be focusing on some examples from the area in which we work, which is economics and finance. Now, Codera are a bunch of economists that are doing data science. And my hope is that our experience will be of interest to other members of the data management community in South Africa. And I'm going to be saying a couple of controversial things, but the point I'm going to try and make is that given the hype around AI and the transformative power of artificial intelligence, we must bear in mind that getting the basics right, there's no getting around the need to get the basics right first. That the things you need to be able to automate processes and models is an enabler of AI. And I think that's something that's widely forgotten at the moment in the race for enterprises to begin to use AI tools. So I'd like to just explain why that is important. And I'm going to be focusing on economic and financial data as a set of use cases. Now, Codera does do a lot of big data work, but unfortunately our main projects are all still under NDA. So I'll be showing some examples that are all public domain. But the important principles that I'd like to emphasize is that at an institutional level, one needs to put certain processes in place and develop certain expertise so that when you start doing more sophisticated things like using machine learning and implementing AI tools, you're able to do that in an efficient and governed way. So there's just no getting around the fact that you need interoperable systems. You need to have developed data pipelines that you can use for automation. You need to have internal capacity and capabilities to understand how models work. And as a result, so you can develop trust in the outputs that you get from using AI tools. So I'll just summarize quickly what we're going to be talking about today. I'm going to try and convince you that automating analytics is incredibly important for a variety of different reasons. And I'm going to show you some examples of what it takes to be able to automate analytics. And then I'll show you some tangible examples from the perspective of different personas. So what are the potential advantages of data-driven analytics? This is a phrase you hear constantly in our community. And one also hears phrases like the ability to extract actionable insights. But what does that actually mean in practice? What I would argue is that the real promise of advanced analytics is the ability to make decisions quicker, to optimize aspects of an enterprise's operations, and identify opportunities more quickly and with greater accuracy. So we have already seen with lots of the clients that we work with that one can not only achieve basic things like cost reduction, but as I'm going to argue today and show you some examples, you can dramatically increase productivity of data managers, of analysts, and help make executives make better decisions. I think a key thing that that enterprises are starting to realize, and I've presented it at previous Dharma sessions on this before, is that data are a potential source of extra income. And so it's important to be able to start developing the capacity to monetize enterprise data and to gain experience in the development of data products that can generate new revenue. And I'll show you some examples of what that looks like. And I'll show you an example of a platform that we're developing that functions as both a data platform and as a marketplace for data. Howard, I see your hand is up.
Yeah, I just wanted to ask you, I'm assuming that all of this automation includes things like data quality, metadata, all of the management of that, and the cataloging of all of the data series that you are. Okay. All right. Thanks.
No, thank you, Howard. You haven't seen the slides, but that's the next. That's exactly what I'd like to talk about. So to be able to achieve these things, I'm going to argue there is no shortcut. That we need to get the basics right. Now, and I've tried to, on this slide, summarize what some of those aspects are. Now, they all involve modernizing, maturing one's enterprise data management. But the good news is that there are increasingly tools that make it possible for you to modernize your infrastructure more and more quickly and take advantage of technological advances as they're occurring. So it's becoming easier to leapfrog and make it possible for you to adopt new ways of work and advances like AI. So just a couple of examples. For us to be able to build data products, for us to be able to monetize data and generate data assets, we need to be able to bring data from different sources together. So we need to be able to have interoperable data from different areas internally and from public domain and third-party sources. We need to be able to have infrastructure that enables automation of various aspects of data management, data analytics, and then software development so that we can actually develop interactive data products. And as Howard alluded to, this includes the ability to quality assure the inputs into models, the models themselves, their outputs, and then the insights that are being generated, or ensuring that data products operate the way that they should be. So there is no, in my opinion, getting around the fact that you need, in your institutions, you need people who are able to validate models, develop models, and understand that the models themselves are operating as they should be and are generating representative outcomes. You really also ultimately want to, if you're using models, you want to be able to track assumptions that are included in them or the judgments that are applied to models, because in practice, we generally don't just use outputs from models as they are. We often apply judgments to them because you have to weigh up different risks. And then this is not just a nice to have. Governance requirements are very important. And so having the ability to bake in any governance requirements that you might have in different contexts into the way that you work. And then lastly, if we're interested in developing data products, if we want to monetize data, you need ways to protect intellectual property and copyright. So I'm going to, this is another way of representing what I would call the analytical value chain. And that, I think, represents the foundation of any automated advanced analytics process. So to double click on what I just said earlier, you want to be able to have all of the data that you need for processes, for decisions at your fingertips. So you want public domain data, data that you subscribe to, like third-party data, and any proprietary internal data you want available in model analytical ready form. You want to be able to manage that in a sophisticated way so that the users of data understand what data they're looking at. So you want metadata that's attached to the data that users have access to. You want to be able to control access at a very fine grain so that you can, once you understand what data is sensitive, you can make sure that only the right people have access to that data once it's classified. And you want to be able to manage inputs into models so that you can quality assure what is being used. You are able to audit what was used, particularly in a banking and finance context. This is very important. And you want to be able to store the model outputs over time so that you can refer back to it and understand and learn from forecast errors, or provide auditors with information on an ad hoc basis. Once you have those building blocks in place, you can begin automating processes. You can automate the things analysts do. So you can automate dashboards, you can automate models. You can also then make it easier to share data and also outputs from models across organizations and keep those alive. And automate any publications and dissemination of official forecasts, either internally or to clients. And then there are a bunch of things that enables you to do at an institution at a level that will add a lot of extra value. Things like being able to learn from your forecast errors, being able to trace your historical assumptions, being able to interactively engage with models and frameworks so that you can make better strategic decisions. And I'm going to show you some examples now of what that looks like in the economics and finance context. Sorry, Howard, you're on mute.
That your historical error assessment seems to be very interesting. What sort of error rate do you tolerate? Is it possible that you can declare that error rate to be too big or too large for the data series to be trusted? Is there a set of quality expectations that you go about around the errors and the quality?
So I think that applies both to input data. So Aidan's on the call with us. Aidan is a data engineer with us who has been responsible for automating our validation of the data that we feed into models. And so there's a range of checks that one could do. For example, you could look for outliers above certain thresholds. You could look for changes in statistical quality over time, and the like. And then for models, what you might tolerate as an error will tend to differ depending on the concepts of interest.
Right.
And there are also lots of frameworks for thinking about how to measure those errors. Later in the presentation, I'm going to show you some tangible examples of how we do it. But it's a very important point because it applies both from a data management perspective and from an analytical perspective. And it's really the ability to, at scale, do those kinds of assessments, have those be automated, and make it possible for only flags to be available to analysts, so that you don't have to manually go through thousands and thousands of models or concepts, because it becomes, for the kinds of data that we deal with, it becomes very difficult.
So you're quite transparent in the current quality of if the input data is going down from a quality point of view, your forecasts are probably going down and everything's going down. And at you want everybody to see what state and what trust you have in the forecasts and the analysis.
That's right. You could think, for example, of formalizing that and have certain quality assurance metrics attached as metadata to certain series in a data management context. But from an econometric modeling perspective, you might also want to flag changes in the statistical properties of the data because you want your models to take that into account. So one example, which I'll show you one of later, is that if you understand shifts in statistical quality of data, you can actually use that in your models to get more accurate projections.
Right.
So in the context of GDP, we've published a lot of work where we've shown that by learning about the error performance of the model you're using, you can actually improve your forecasts. And we have managed to build automated models that can produce that can beat models that are produced by large teams of analysts by making this part of the DNA of how you do modeling. Okay, so what I'm going to do today is show you a range of different examples that span what I've described as the analytical value chain. Everything from automating the data that you need for modeling, automating the models themselves, making it possible for you to track your judgments and manage your forecasting system, making sure that you can develop the outputs from models into sophisticated storytelling visuals and interactive visuals that you can use to convince, to raise questions, and communicate findings. And then lastly, to make them truly interactive, to make it possible at an executive level for executives to ask questions of the frameworks that are being used, to do that in real time, so have the models able to be adjusted, different assumptions to be inputted, and really to enable the development of strategic planning tools, optimization frameworks, and really this is what data products are all about in an economic and finance context. So what I'm going to try and do is I'm going to focus on the 4 different personas that I know are part of the Dharma way of looking at the world. So I'm going to start by looking at how to think about these challenges from a data citizen's perspective. So this is a user of data. And I'm going to focus on our data management platform, EconData, as an example, in the hope that our journey will be relevant to the same journey that lots of others in the community are on at the moment. So the key challenge that we face, not just in South Africa, but internationally, is that there is a wealth of public domain data available, but it's usually published in a way that isn't easily usable. So here's a screenshot of some statistics from Statistics South Africa, and you can see that you have the data published firstly in an Excel spreadsheet form as a snapshot, which means it's hard to get time series of the data without manually copying spreadsheets over. But you can see that actually constructing time series of individual concepts can be quite complicated because you've got lots of different line items and lot that relate to different columns. It can be non-trivial to create data sets that use economic and financial concepts, particularly when really you want to be able to access this data in a programmatic form so that you can automate processes. So what we do as part of our work with EconData is to make it easy for people to access whatever public domain data they want to use in a model or analytics ready form, so that they can and then make that data available using any analytical tool. So for example, if you want to use R or Python to build models, but also make it possible through automation that the underlying data is always up to date, and that there's rigorous quality assurance to make sure that the data that's in the database actually is what was published, and that there is detailed metadata so that as a user you can understand what the data means and that you're using the right data. So for those of you that haven't met us before, you can go and sign up to Econdata for free at econdata.co.za. And we have a tremendous amount of public domain data for South Africa already available. We're always adding more data to it, and we make most of the data available for free. Because we follow a freemium model, we do have subscriber-only data sets, but we use that to fund the continued expansion of the data that we make available. Something that I think is worth emphasizing is that in an economics and finance context, we really need real-time data. Real-time data is data that was as published at a specific point in time, because economic data in particular is revised often, which means that you need to train your models on data that was available at a specific point in time, so that you can actually make sure that if you were to put it into production, it would perform well. If you use final vintage data only, then you're going to get an incorrect assessment of the model's performance in production. So we make the full lineage of data available, as well as versions of the data if the definitions of data are changed over time. And this is also important if you are interested in methodology and you want to develop indicators, or you're a researcher. Just to give you a practical example of what we mean by data democratization, and this is true, at a societal level, and it's true at an enterprise level. It means that users are able to see what data is available. They're able to search and find the data that they want, and they're able to understand what they're looking at. So in an economic context, it could be understanding whether you are looking at nominal or real GDP. Those are basically values or volumes. And understanding whether the series was seasonally adjusted or not. Econdata makes detailed metadata available attached to every series, which means that as a user, you can understand what the units are, you can understand where the data is from. There's a mnemonic so that you can automate access to the data using any tool that you want, and you can download the data into Excel if you want to work that way. And again, the availability of a glossary of not just the actual time series, but detailed metadata, and I'll show you an example of our registry later, is crucial for enterprise or public data democratization. As I said, what interoperability means in practice is the ability for a user to use whatever tool they want to interact with the data. In our case, R is incredibly powerful for statistical modeling and econometrics, and Python provides incredible functionality for particularly things like machine learning at scale. Of course, many people still work in Excel, and even if you work in Excel, the important thing is to be able to enable someone to use and interact with data, whatever tool they want. And so by making data available in Excel, users don't have to change the way they work, but they can still automate their chart packs, even if they work in Excel. And as I'll show you later, we can actually, our web app can actually deploy models into Excel, so that you can have the functionality that you would have if you were using a dashboarding tool, but you can deploy it in Excel, which makes it very powerful, because anyone in the institution can use something without extra training. Now, I know this was advertised as a big data talk, but I'd like to emphasize that even for the kinds of economic and financial data that we use, the data very quickly becomes very big. So here I've got a screenshot of just one of our modules, which is a public finance module. that uses data from National Treasury. And just that module has over 100,000 individual economic concepts drawn from millions of rows of information. And what we have done is structure that so that the individual concepts have detailed metadata attached to them. And now you can programmatically analyze data at that kind of scale. Because you can't open an Excel spreadsheet with thousands of different concepts in it. So, but we do a lot of work with even larger data sets. But if you wanted more information, you can go look at our user guide. So part of the public service that we provide is for public domain data. We make an enormous amount of data, metadata available. So the team structures data sets, and then as a public service provides detailed information on the data definitions that are available. Let's look at this from the perspective of a data manager. You can think of a data manager in an enterprise concept as being a data steward, for example. Now, the key challenge that lots of institutions have is centralizing their data management. What we do with Econ Data is we make it possible to rapidly integrate data from different sources and centralize access without necessarily centralizing the data management. So we make it possible to access third-party data through scripts. Then we make it possible to access both proprietary data that's internal to our clients, but also public domain data in a model-ready format, so that whatever data is managed through Econ Data can be made available to staff across teams, and that as data is added, it automatically becomes part of the glossary that enables the group to understand what they have, to understand the security classification of the data and what the data mean. And once everything is managed that way, then you can automate workflows. Now, this seems trivial, but it is a really big challenge in large financial institutions when there are lots of legacy systems. And what most institutions do is they try and follow a top-down approach to build another data management system to rule them all. And it becomes very, very difficult to manage at scale. So because our team come from a banking background, we have built Econ Data to make it possible to deploy rapidly, and within a couple of months have all the data that analysts need ready for models and for automation. I'll show you some examples of this, but first I just want to touch on the information model that we use. So if we use a data standard called SDMX, so that stands for Statistical Data and Metadata Exchange. Now that's an ISO standard that has been widely adopted as a global standard for data exchange. SDMX is promoted by national statistical agencies like Eurostat and large multilateral institutions like the World Bank, IMF, BIS, OECD, and others. And we believe that over time, many banks and statistical agencies will be moving to this standard. Statistics South Africa has already announced that it will be moving over the next 10 years. And it is particularly important in an economics and financial context because what SDMX does is it bakes in the management of metadata alongside the data that's managed, and making it easy to share the data and the metadata across institutions. And so it ensures that data is interoperable and that data can be accessed using whatever tool analysts want to use. Importantly, even though it's very difficult to get started using SDMX, once it's in place, it means that there's very strong data governance processes that have to be followed when the data is accessed, which is a really important thing in a banking and finance context where regulations require the ability to audit and control access. I'll give you one example. So because though we provide both an automated approach to validation, I wanted to show you what manual data validation looks like in Econ Data. So as a data steward, in a context where you may be loading forecasts, we have a front end that enables a user to load forecast scenarios and label them as preliminary or as official or finalized, and visually validate the data. So we also run automated scripts to make sure that the data that's being added is in line with previous vintages and is quality assured. But a data steward can also do this manually if they want to load an Excel file and don't want to follow an automated process for it. We are also doing a lot of work to develop our registry to be able for data managers to be able to visualize the relationship between the metadata and data that is being managed, to be able to create knowledge graphs that are double clickable so that the various aspects associated with the management of the data can be quality assured and audited over time. So for example, there may be provision agreements that make certain data sets available and control who is allowed to see data and what's allowed to be used for, and what it's allowed to be used for. And you may want to be able to think about how over time the data structures and the dimensions of data might change. So you might want to be able to have multiple stacks of the same version of economic concepts, but you want to be able to distinguish between them so that you can roll back and look at what a long time series of a concept might have looked like, and enable analysts to construct their own concepts using all of the underlying concepts that are available. Next, I'd like to look at this from the perspective of a data professional. So you could think of a data professional as being an analyst that actually builds models. And here, I hope to convince you that using the kinds of tools that I'm describing can 3x the productivity of an analyst. And I'm going to show you some examples. And the reason automation holds such tremendous potential for analytics in particular is because analysts are able to templatize their workflows so that every single model they build, every chart pack they develop, every dashboard they build becomes part of their toolkit over time. And they don't have to go through a lot of manual effort to update their outputs, but they instead can focus their energy on building things that add value. So improving their judgments, building new models, and making every time they build a model, they make it part of their toolkit that they can take forward. And once that's actually embedded in the institutional way of work, those kinds of tools then become part of the institutional memory and become available to other members and other teams. So, and I'll show you some examples of the kind of sophisticated analytics that one can do once you have the bedrock infrastructure in place, once you have automated data and infrastructure for automation of models. And I'll show you what that looks like tangibly. So here is an example, and we provide a link to our website where we provide the code snippet. But here we show how you can automate a model that uses public domain information that you can access for free and you can produce a density forecast in about 12 lines of code. So on the one hand, it becomes trivially easy to maintain sophisticated models, but it's also a way to really change the way of work in an institution, change what it means to be an analyst. Once things that look sophisticated and complicated become trivially easy for someone to do. Here's an example of an automated dashboard that does a comparison that does analytics of monetary policy decisions, and, for example, looks at the Reserve Bank's policy rate compared to quite a common model that's used to assess what the appropriate policy rate might be given macroeconomic fundamentals. This is fully automated and available for free on our website. So, and if you click on the next tab, you'll see that we have automated forecast analytics. And Howard, this speaks to your question earlier. You can see, for example, in something like inflation, CPI, that the forecast errors have generally been quite similar over different periods. But you can see that they're also generally a little bit smaller than for GDP sometimes. So GDP from 2020 onwards, or if we include the COVID pandemic, the forecast errors from the Reserve Bank, so these are the Reserve Bank's forecast errors, have been much larger for GDP than they've been for CPI. And
is there a reason for that, Daan? Is there a reason why they're battling?
Well, it's because, firstly, it's much harder to forecast GDP than it is CPI.
Okay.
So we've got 2 journal articles where we've used big data techniques to do CPI and GDP projections. And the first answer is there's a lot of volatility in GDP that make it quite difficult. There's a lot of inertia in CPI that make it easier to project. And there's a lot of things that we know about the future that models don't necessarily know about. So particularly in CPI, judgment can help you make forecasts better. So for example, if you can make a good assumption about what the NERSA allowance for increases in electricity prices might be, or if you can do good analysis of what's going on in the medical insurance industry, you can get, as an analyst, you can improve a model's performance in the case of CPI quite a lot. Importantly, you can also look at the distribution of errors. And so you can see here, these are the Reserve Bank's errors. You can see that these look a lot more normally distributed than it does for GDP. And partly this is pushed around by the fact that no one saw the COVID pandemic coming, and that was like a Six Sigma event. So that's partly, this distribution is partly biased by that. But if you're a statistician, it's really important to understand the distribution of errors because that helps you assess your models. And so again, this is an example for publicly provided forecasts, but the same principle applies. You can, as an institution, track your errors, as an analyst, track your errors, and use your performance to force yourself to ask questions about what judgments am I getting wrong? Should I be using a different model? What should I improve? What aspects of my forecast are causing me to perform poorly? Next, I'd like to give you some examples from the perspective of a data executive. You could think of this as someone in the C-suite, a chief data officer, for example, or someone that's responsible for strategy. And from their perspective, what really matters is being able to have the tools that they trust available to ask questions, to be able to do what-if analytics, to be able to do sophisticated risk management, to understand how different choices would affect their institution, given different macroeconomic or industry scenarios. And in order to do that, you need the data to be available. You need models to be live, and you need analysts that are able to run those scenarios in front of you. So there's analytical infrastructure that forms the bedrock of that kind of capability. And what I've been arguing is that focusing on just individual AI applications does not help institutions realize the true potential of what modernization and automation enables beyond just narrowly AI. The kind of cost benefits, cost savings, the kind of optimization, the kind of improvements in strategic management that are possible if you have an analytical foundation that enables this kind of way of work is really what is transformative. I'll give you some practical examples. Again, this comes from our world, but I imagine that in your context, there'll be similar examples. Howard.
Yeah, I was just thinking about this type of executive and what would the benefit be of maybe using generative AI or conversational AI, where they could be asking the generative AI to build the models or to change what needs to be done that the analysts would do. Is that something you're thinking of?
So you might consider me conservative in this respect, but as our team have worked on a variety of different modeling techniques, lots of different machine learning frameworks over time. And in my opinion, unless you have a really good understanding of the way the models are working, one should have a very healthy skepticism of automated machine learning frameworks, for example. Now, there are exceptions. ChatGPT can be very good as an example. But I think in a financial and economic context where it's not just about accuracy, it's often also about storytelling ability. It is crucially important that analysts can actually build the models themselves. Because by having the capacity to build models themselves, you understand whether the outputs you're getting make sense. You understand how features of the models affect the outputs that you're getting and help you assess their performance over time. I'll give you one example. We do a lot of FX forecasting, and in our experience, you can build very sophisticated models with using sophisticated machine learning techniques and get absolutely terrible forecasts if your focus is on the wrong things. And it's very difficult to really have a good intuition of whether automated models are working as intended unless you build them from scratch. So there could be a future where things improve dramatically, but I believe very strongly that you need to get the basics in place. It's a necessary rung on the ladder towards the broader use of generative AI. I really feel strongly that jumping to specific implementations of such models without having fully matured data management and analytical capacity in one's institution creates lots of risks.
Sorry, I was actually thinking of you using either an SLM or an LLM on top of your system, not on independently, because you've got the glossary, you've got the metadata. It should be able to, and you don't want to feed it external data. You just want to feed it your data, your models.
So I think there are lots of ways that kind of application makes sense in this context. Aidan, who's also on the call, has done lots of work where the metadata attached to our data sets are actually using language models. The data's cleaned. So there are lots of things like that one can do to make life easier. But again, I think that works well in a context where analysts really understand they've got the basics in place.
Okay.
Yeah, so let me show you a tangible example of what this looks like. Because everybody, will roll their eyes at me when I say, how important automated dashboards are, because many people have been disappointed in their ability to actually provide useful insights, actionable insights. Here's an example of a fully automated nowcast of GDP and unemployment, which is available for free on our website. It's one of the only systems like this globally. And it's interactive. You can look how each Thursday our data set's updated. Every Friday, the model produces a new nowcast. And then so that's basically a projection of current quarter GDP because the data lags and is not available in real time. So as new data comes out, the model allows you to see what the impact of different data outturns have been for the nowcast. So this allows you to tell stories, to be able to start asking questions. We don't use automated systems without health checks, but this is a very useful way to get some initial, to form some initial hypotheses about what's going on and to know what to dig into as an economist. So these kinds of tools make it possible for you to very quickly assimilate a lot of information. In this case, the model uses, I think, around 57 indicators of different frequencies. And so you can crunch a lot of information consistently over time and understand where to put your analytical effort. I'd also like to show you an example. This is deployed in Excel of an interactive set of forecast models and analytics that you can use for strategic decisions like hedging. So you can see there's a drop-down menu, and you can choose different models. You can assess the probability of the rand being at a specific level on a specific date. And you can look at a density forecast. You can apply judgment. So you could use option market information to say, is the market pricing higher or lower risk to the exchange rate? And then we're busy developing a hedging module, which you can then use to actually make hedging decisions dynamically depending on your expected cash flows. And you can see you can go to our website to look at a demo. So whether you work in Excel, whether you're a coder and use other tools, the underlying principle is that you need automated data, you need models that are capable of automation, you need striking visualizations and interactivity, the ability to ask questions of the data, ask questions of the models, and ask what if questions about changing strategic decisions to be able to make optimization changes and optimization choices. For me, that is what is important if we are to realize the kinds of opportunities that changes in technology provide. And so even though there's understandably a lot of hype about AI, I think short term, there are big returns on investment in just doing the basics better, modernizing data management, modernizing the kind of analytical, the use of simple analytical tools, picking the low-hanging fruit, and then being in a position to better leverage sophisticated technologies like AI once you've got the right foundations in place. I think I'll stop there. I'm happy to take questions.
Thanks, Daan. Thank you very much. So, guys, please, if you have any questions, please could you put your hands up, and then I'll try to just control access. I don't see anything in the chat. There's some questions from me, but anyone else? Yes, Michael.
Yeah, hi. I was just wondering, with regard to automation, what kinds of automation tools you use? Is a combination of overnight batch scripting? Do you use like Microsoft Power Platform, Automation Anywhere, and other RPA tools, or just a collage of different tools?
So on the data management, our platform enables automatic ingestion of data and validation, but we still have human checks in place as well. Then on models for automation, we use other scheduled running of models. So whether that's in R or Python. But perhaps Aidan, do you want to comment on this?
Yeah, we run R scripts which have the code to engineer data as it's published by suppliers, and it's running on a server on a cron job, a whole series of cron jobs. Yeah, and then that's sort of loaded onto our platform with the with a function. So it loads it into like the SQL table using an R package that communicates with our API. Then in terms of the validation process, the results at the moment we're saving the results internally to Google Sheets. That involves like tables of like outliers and differences between vintages. So I think a question also that Howard had was whether we publish those validation results. I don't know if, Daan, you want to mention if you're interested in making those results available in future outside of our internal environment.
Yes, so part of our hope is basically to attach quality assurance to specific series to publish. You can, if you go to our blog, we publish 2 blog posts a day, and a lot of the kinds of things we publish are things like analysis of revisions to statistical series. We do a lot of work on, we sometimes do special topics where we look at how the statistical properties of different economic and financial series have changed over time. But as Aidan mentioned, our hope long term is to actually bake that into our data management system. Maybe just to add, you can also go to our Econdata site and look at our user guide, where we've added a lot of content that is auto-updated charts, for example. Some very sophisticated charts that draw on big data that describe how things are changing in terms of cross-holding of investment funds or public finance information, for example.
Cool, thanks. I was just going to say that also, seeing as you're a firm and you have other shared services, for example, like finance and HR, so they'll be doing automation. It's not necessarily with the core data products that you use, and they probably want to have everything, maybe leverage as many of the platform tools as they can, if possible.
Yes, that's an important point. But I think the good news is that increasingly, even if you have a relatively complex tech stack, the tools can often talk to each other. So you can increasingly, it becomes a little bit easier to integrate them, even if some of them are legacy tools.
Cool, thanks.
I also want to mention that something that's quite useful internally is our calendar feed, like that we can push onto an electronic calendar. So we've got a script that scrapes dates and times of publications from data suppliers from their websites, and then we load that onto like an electronic calendar. And then we use that for like automating some information and flows in our processes.
Great, thanks, Michael. So if I'm correct, a lot of it's around cron jobs. You're using cron jobs to automate the different tasks in the background to run at whatever time. Okay. Any other questions?
Yeah. Hi.
Yes, Martin.
Martin. Yeah, I'm curious. When you say automated dashboards, what exactly do you mean with automated part? I mean, they do just adjustment of parameters, or they can even change metrics that you automatically change a metric, something. Because for me, most dashboards usually, once you build the designed one, updating the dashboard, that's definitely is an automated activity. That's what you mean. So automated in the sense that they're ready, they automatically are updated and refresh themselves without any interference.
Yeah, I think they
Or-
usually update themselves, especially because we set up some tasks like with the banking dashboard. Just let me point out that a lot of our data is only updated about once a month at the most in highest frequency. So it's not very intensive as like every day, but then we usually have a task, say once a month, that updates maybe a SQL database for a dashboard in the back end, and then the dashboard relies on the calculated data from that database to load more quickly. Yeah.
Okay. So yeah, so the answer is we don't even though we run algorithms that we've done work where we run algorithms that are using intraday data for a lot of our public facing work. That's generally updated on a scheduled basis. But that's because we know when the data is released and we can schedule the work.
Okay, thanks.
I hope that answers your question.
Yeah, thank you.
While we're waiting for another question, you can go and look at some of our examples. We've got lots of demos in our Analytics lab, and then we publish, as I said, twice daily blog posts where we try and demonstrate the value of public domain data for understanding what is going on, both internationally and in South Africa. And you can subscribe to our newsletter, or you can just follow us on LinkedIn or Twitter.
We've also had a trend of using code to update graphs at a regular frequency on our econ data blog. Say, for example, with the quarterly labor force survey, we've got like a suite of graphs that we would update when that data gets released, and we just run the code, and then we can just upload those static graphs very quickly within, like including the human checks. It would take up to half an hour to like say publish them. So that's also in some sense automated because it relies on code that just gets run.
Hayden, when I go to a CISO, where should I look for those charts?
Oh yeah, just click on analysis.
Okay, there we go. So these are examples of charts that, because the CISO data is published at a quarterly frequency, it's not, it doesn't change all the time. So we can schedule the updates and that are pushed to the website.
Great. Don, the question I had, there's a new standard come out called Banking Integrated Reporting Dictionary. I don't know if you've seen it. It comes from ECB, and so it's basically a dictionary of all of the data elements from credit card reporting, or credit reporting, sorry, not credit card. Is there any work that you're doing in that area?
No, I'd have to go and look at it. But I think without knowing what that standard looks like, my gut feel would be that SDMX is just the data information model. The exact kind of regulatory requirements for reporting, are a level up from that. Now,
Right.
I think the advantage of something like SDMX is that it creates the kinds of capabilities where, irrespective of the actual regulatory templates for reporting, it can be managed using SDMX as the undergirding data information model. But I can't speak to whether that's the case in the example that you're mentioning.
So I've actually got the link in the chat. So I was actually asked by the Saudi central bank, and they seem to be wanting to move to this standard or in the process.
Thank you. I'll definitely look at it.
Okay, great.
But I
I've
think
downloaded all of the dictionary, all the metadata elements, and have started to bring it into Power BI, but I thought maybe you've got some of it already.
yeah, I guess it depends. Our focus is very much on South Africa, but we're building out an international module.
Right.
So in terms of the data access, and then the clients we work with, we actually do implementations of econ data to do forecast management using proprietary data. So what you see on the public-facing website is our open free product, and then we for clients we basically automate processes, create indicators, and the like.
Okay, great. Fantastic. Anybody else? Are there any other questions? What about Adam? Adam, you normally have a question or two.
No questions, just to say it looks fantastic and really inspiring.
Okay, great.
Well, maybe
Thank you.
Howard, I should close by just saying thank you. I think before Martin has a go, just that our platform is meant to be a community project. Our original hope was to make it completely open, but for commercial reasons we have to fund the addition of public domain data by charging enterprises. But our hope is basically to make as much public domain data as we can feasibly structure available, and we are working on making African data available and lots of other international data, particularly hard to use data sets. So we are very passionate about democratizing data. If you'd like to join us and work with us, please get in touch.
Now we see Raf here, and I'm sure Raf's in Saudi. Any ideas from your side, Raf?
Oh, hi. Thank
Hi.
you. Interesting topic. Unfortunately, I didn't attend in the beginning of the session, so I don't have any idea for
Okay.
now. Thank you so much.
Okay, thank you. Yes, Martin, I think you were going to say something.
No, just saying that I really like to enjoy this presentation. Fortunately, the next probably one of my last ones, because I having start a new project, data engineering thing, and I
Okay.
won't have time to attend the sessions
Okay.
anymore. It's very sad, but